In question 12, we need to complete this decay schemes. Answer 12. So here the first one will be, this is the alpha particle, so this will remain 56. Then in the second one, this will be there. Third one, this will be there. In question 13, this decay process is given. What is the energy of neutrino and what is the momentum of this neutrino? Solution 13. So A part, energy of positron is given. .650 MeV. Energy of neutrino 0.650 minus kinetic energy of the situation. So 0.650 minus 0.150, 0.5 MeV, or you can also call this 500 keV. B part, momentum of neutrino, energy by speed into 10 to the power 3. So this will be 2.67 into 10 to the power minus 22 kilogram meter per second. In question 14, we need to write the equation showing the end products and find the Q values. Solution 14, first one. So what we will have is this. Let me first write the left part. So here we will have calcium, then here we will have argon, then here we will have argon, and this situation is also there. So now the Q values, B part. So Q value is the mass of reactants minus mass of products into C square. So let's put the values. So at the place of C square we can write 931 MeV. UC square, we can write this 931 MeV. So it will come 1.3034 MeV. So similarly for others you can easily find it. In question 15, write down the nuclear process taking place. Solution 15. So the process that is happening is this. Finally, this will be the equation. In question 16, we need to find maximum energy a positron can have in beta positive decay. Solution 16. So energy which is liberated here is 11.014 minus 11.0093 U, which will give us 29.5127 MeV. So ultimately this will be the maximum kinetic energy. This can be the maximum kinetic energy of the positron. In question 17, calculate the kinetic energy of alpha particles. Solution 17. So here what we will be having is kinetic energy of alpha particle equal to energy of thorium minus energy of radium plus alpha. So ultimately we will have 228.028726 to 931 minus 208,563.0195 plus 4.00260 into 931, which will give us 5.30383 MeV. In question 18, calculate the maximum kinetic energy of beta particles. So this is solution 18. So we will have this scenario. Now net reaction is something like this. This is 4.43 MeV, by the way. So energy of positron plus C will be minus, yes. So when we put all the values, let's put the values. 12.018613 U minus 12 U minus 4.43 U. So after simplifying everything, we will get 12.89 MeV. This is in MeV. Remember, convert this U into MeV. In question 19, we need to find the half-life, average life and time will be taken for converting 25% of mercury into gold. Solution 19. So first part, the half-life. 0.693 by lambda. So when we put all the values, we will get 3820 seconds. Average life, half life over 0.693 come out. This is, by the way, 64 minutes, and this will come out to be 92 minutes. Then the time for that much, 25% to decay, so ln 0.75. So from here T will come out to be 1598.23 seconds. In question 20, we need to find activity and what will be the activity after 7 days. Solution 20, A part. So N naught over 198 into 1 microgram, 6 into 10 to the power 23 into 1 into 10 to the power minus 6 over 198 atoms. Activity is lambda n, 0.693 half-life into n, which is 6 into 10 to the power 17, 198 into 2.7. So this will be around 0.244 curie, and also we need to convert it into seconds, so that's why multiply this by this also. B part, A will be A naught by T 2T half, so 0.244, 2 into 7 by 0.7, 2.7, 0.040 curie. In question 21, what is the activity at T equal to 4 days and what is the decay constant? Solution 21, A part, A naught e to the power minus lambda t, 20 into 10 to the power minus 6 e to the power minus 0.693 over half-life into 4. It will come out to be 14 micro curie. B part, lambda will be 0.693 over 8 into 24 into 3600. This is the half-life, 26 into 10 to the power minus 6. In question 22, we need to find the average life, half-life, and factor does the activity of sample decrease. Solution 22, A part. So average life will be 1 by lambda, 1 over 4.9 into 10 to the power minus 18, 1 over 4.9, 10 to the power minus 18 second. Half-life 0.693 by lambda, that is 4.9, 10 to the power minus 18, so 4.5 into 10 to the power 9 years. Activity it will be 2 to the power t half, so A naught by A, it will come out to be 4. In question 23, what is the decay constant and the half-life? Solution 24. So solution 23. A part, decay constant will be obtained by this equation. So it will be 3.05 10 to the power minus 4 seconds, and half-life 0.693 divided by lambda 2272.13 seconds. In question 24, what will be the count rate 100 hours after the beginning? Solution 24. So A dash will be A naught 2 t half. So A naught by A dash will be around 4, and T by T half T half will be 20 hours by 2, that is 10 hours. A double dash A naught over, so this time so it will be 3.9 10 to the power 3 disintegrations per second. In question 25, calculate the activity of 0.1 gram of RaCl2 in which all radium is in form of radium 226. Solution 25. So 0.1 gram 1 over 297, 0.1 mole of radium. So 0.1 into over equal to, so this will remain. So lambda will be equal to 0.693 half-life. So activity lambda n, that is 371 and 2.027 into 10 to the power 20. .8 into 10 to the power 9 disintegrations per second. In question 29, half-life is given. Find the total number of disintegration in 10th hour. Solution 26. So number left after 9th hour will be lambda n9, A9 by lambda 0.536, 3.7, 3600 to convert in seconds over 0.693. So it will give us around 103.023 into 10 to the power 13. So activity after 10 hours, A naught E minus lambda T. 1 into E minus 0.693 over 10 into 9.5 curie. Number of atoms left after 10 hours, lambda and 10. So here we will have N10 to be 3600.693 by 10. So it will be around 96.103. So we have found for 9th hour, we have found for 10th hour. So number of disintegration between this period will be 103 minus 96. It will come out to be 6.92 into 10 to the power 13. In question 27, what will be the second hand rate of a 1 month old source if it has originally purchased for 800 rupees? So this is solution 27. So A naught E minus lambda T 800 into 0.23369 187 rupees approximately. In question 28, how much time will elapse before the emission rate of gamma ray drops to 2.5 into 10 to the power 9 per second? Solution 28. So according to question, will drop to half when beta decay half to original value. So this sample would take 270 days. So therefore time required will be 270 days. Question 29, how much time will elapse before mixture of 90% carbon 11 and 10% boron 11 convert itself into 10% carbon 11 and 90% boron 11? Solution 29. So A part, this is there, and B carbon boron, initially 90%, 10%, finally 10% and 90%. So 10 N naught equal to 90 N naught. So 1 by 9. So it will give us around this much. So T will come out to be around 64.36 minutes. In question 30, we need to find activity, number of decay and number of decays in different times. Solution 30. A part activity will be dN by dt or lambda n 0.693 half life into n, which is 4 into 10 to the power 23. Half life is 12.3. 7.146 10 to the power 14 disintegrations per second. B part dN by dt. So number of decays in next 10 hours. So it will give us 2.57, 10 to the power 19. And in last case, 4 minus 2.82, 10 to the power 23, 1.18 into 10 to the power 23.